let's do it.
All right, man. Well, thanks for joining me on this one, John. I do appreciate your time.
Dude, of course, when simulation's involved, I'm always down. So, it's a good time. It's a good time.
Yeah, that is the truth, man. You say that, and that is always the case. I appreciate you for it a lot because, I consider myself a real expert of SOLIDWORKS simulation. I'm just going to say it at this point. I feel like I know every button in the SOLIDWORKS simulation environment, flow sim and structural analysis, really well. Um, And I do use the Simulia tools quite a bit now. I've had them at my fingertips now for 5 years. In the last couple years, I've used them more and more just because they've had so much development, you know. But I definitely lean on you and consider you my, Simulia guru. So yeah, I appreciate you just kind of answering some of my questions and taking me through this stuff today.
Hey, absolutely. Yeah, no, it's fun and it's incredible what it can do. I mean, like you mentioned, I'll kind of live and breathe the SolidWorks simulation side as well. I've taught countless people and things with that. But what what kind of taking that step, yeah, the step forward, a step above there with Simulia, it is just cool. So,
Yeah, I mean,
yeah, no, happy to be here.
I've always thought, the SOLIDWORKS simulation is for every SOLIDWORKS user. It takes you when you start at the beginning, it's for everybody. Again, in the professional level, maybe engineers use that more. And then I always thought, oh, these tools like Abacus, high-end nonlinear stuff, that's for like PhD, just guys who are the analyst crown only. And so I kind of stayed away from that environment, thinking it was beyond me. But after I got into it and I saw how familiar it was for me doing so much FEA and CFD and SolidWorks, you know, it it really wasn't that crazy for me. Did you use other FEA tools, before SolidWorks?
Yeah, so did some I was doing on that front. I mean, probably SolidWorks most heavily was doing on there. Before this, I was over at Northrop Grumman, some of their aspects on there, and
Oh,
for a lot of their design things there, they're using kind of the legacy version of Abacus, or they're doing on that front. I was doing, and then yeah, back a while ago in school, was doing on there, just different aspects. But it's I mean, it's cool. I mean, like you mentioned there with SolidWorks simulation, I mean, it's such a great tool, especially for what it does on there. With it, it's like, hey, integrated right there into like your CAD models and things with that. On there, I mean, really built as like, hey, so anyone can use it, but it's absolutely true. Hey, once you go into this higher level Simulia, is that it sometimes has this like bigger connotation, like, hey, you have to have a PhD. What's doing on there with it? But
yeah,
it's cool. I mean, even working with a lot of different people on there. I mean, taking people that know nothing about FEA and just started them right into Simulia. I'm on there and kind of take them to see success or developing workflows on there, or taking
yeah.
people that are very familiar with simulation and kind of bring them up. Um,
I
but
mean,
yeah,
that's really what I've been impressed with their scene because I thought when this came in that that's not something that's possible. But I mean, then as I figured like, well, now I realize that I can do it. Then I'm like, well, kind of any SolidWorks user can do it then. And now I've seen a bunch of examples of customers who have come to this directly. Like they needed some physical need that SolidWorks doesn't have. They didn't have FEA background. They came into this directly, very successful. And so I've kind of changed my tune on it that we can say like, oh no, you can do this. You don't have to, yeah, you have a master's degree or anything to get into this. You'll need some help, but it's possible. Well, maybe before we get to that, I know you have some stuff to show as well. I'm gonna pull your screen up here, and maybe we should talk a little bit of licensing because we already said SOLIDWORKS simulation, Abacus, and Simulia, and I think most people beyond us are not really clear on what
Yeah, no,
those three
it's
things
so
are.
true. It's like, hey, just throwing out these buzzwords of like, all right, what is this? What's this actually mean on there with it? Yeah, and I have this one PowerPoint here. Basically, it's a conversation. I could call it a conversation starter on there. Bunch of different directions I can kind of go on here with it, just to kind of help with there. But I mean, as far as high level on there, just from like a licensing, SolidWorks simulation. I'll actually go into it on here. Let me go into a couple things.
Oh, yeah, this is
Yeah, SolidWorks
nice.
simulation. Yeah, so this is grand. So this is open. I went on the wrong one there. So let me see. All right, there we go. Yeah, so SolidWorks simulation. I mean, there's kind of like three tiers of licensing on there, but really your kind of main core, like, hey, I'm solving structural problems, going on there, and your base one's like your linear static, which I mean, you're going into there. I mean, you're well aware of what it's doing. Is like, hey, you have linear materials, basically you aren't like permanently deforming it, what you're doing on that front, kind of small displacements. But you're answering questions, hey, will it break, or the structures, things on there
Yeah,
with it, and it does a great job.
and
Great
that's the
job on there.
one. That linear static one's the one that comes in SolidWorks Premium too. So a lot of folks just have a SolidWorks Premium license, and they're familiar with the linear static analysis that's here on Sim Standard. And honestly, I'm pretty familiar with these, especially Sim Pro. I think is the most common place for sim users, for SolidWorks sim users to be, because you've got optimization there, or they need some output like right like frequency thermal. The place that I've always been shakier is in Sim Premium. Honestly, myself, I've been pretty confident there with composites, right? Like if you need to run, a carbon fiber layup, you just need to have that license to basically do that. And some linear dynamic. The nonlinear stuff I've done in there has been like sealing applications, but not real heavy nonlinear stuff, like not super large strain problems. So I take it that's usually where this licensing runs out, right?
Exactly. You've nailed on the head on there. And yeah, you do have this basic nonlinear solver of what you're doing here in SolidWorks simulation, but once your basically contacts get more complex or you're getting higher strains, things with that, that's where really you need that kind of Simulia package, and it, I mean, has yeah world-class nonlinear solver
Okay,
with what you're doing
so
on there.
where do we go from here? We go, okay, we need something higher than what we can have here. Nonlinear would be one. Explicit dynamic, right? Like high speed crash type events.
Yeah, and it's cool. Actually, I'll go over to the kind of licensing on the Simulia just for what it's doing on here. Now, with just high level, I'll just kind of ignore this one on the left. This is kind of a similar capability as SolidWorks simulation on it there, but
Okay.
really what we're going on is this two on the left. So like, hey, your nonlinear is kind of your main one, and that explicit. Now, one thing I'll on their explicit dynamic, that is just where you see like all these like kind of cool simulation videos, things like there. Those are all using kind of the explicit solver. That one's kind of used in two different applications. Your one, like you had mentioned there, you're very high speed, like hey, you're a car crash, like hey, this is used to analyze car crash, was doing there ballistics, was doing kind of more complex drop tests and things with that. But also because of the efficiencies behind the scene, where it's like really really good with contacts on it, there is
Hmm.
that even if you don't have like a really dynamic event, you use it for basically more complex contact scenarios where it's like it's really not like a dynamic problem, but using the efficiency of the solver to kind of solve these complex contacts. So like one example of that would be like sheet metal forming, for example. Your
Mm.
sheet metal forming, like tons of like contacts and changing and large strain things on there, is that your basic nonlinear, your implicit solver is what they call it on there, really kind of reaches limit even within the abacus side over there. But then you go to your explicit on your abacus on there, and you can try and use that efficiencies of that to like solve these just wild problems. I
Okay.
say wild, but really really cool on there.
Yeah, for sure. I mean, so what I'm hearing is like, yeah, okay, over SolidWorks, we want to go to higher nonlinear stuff, which could be well beyond permanent deformation. It could be large strain stuff. We might want to do high-speed explicit events that will come here. And then the contact over here as well, the default is that you've got kind of a sliding interaction between components, right? Over in SolidWorks, our default is that things are welded when they're touching, and then generally we'll do a good amount of work to say, hey, this is a bolted connection, or these things are sliding. And in SOLIDWORKS 2, we increase the solve time quite a lot when we have sliding interaction or contact interaction. But over here, you're saying, hey, that's the default is that things are sliding, kind of contact interaction, and we have a more efficient way to deal with that. Is that fair?
Exactly. So I mean, in SolidWorks simulation, you do have contact things there, but it just handles it very, yeah, like I said, very efficiently. There's this really cool functionality inside of abacus just called your general contact, and more or less what it is in there is like, hey, anywhere that may come in contact, it takes care of it on it
Okay.
there. So like
Yeah.
I may show this uh
So it's
later
kind of like
on, but there's
our
this little
our global default in SolidWorks, which is
it,
is bonded. Over here, you have a global contact, but it's not bonded. It's that real world collision.
yes. And the one in SolidWorks, it will just basically take into account anything that's kind of like touching or close to touching to begin with on it there. But in Abacus, because you're like usually having high strains, high deformation, where like parts are changing, like hey, you could have a part that start of the analysis are way apart from each other, but then they're touching once you get part way through the analysis.
Hmm.
Is that general contact? Hey, it takes care of that because in SolidWorks simulation does a great job, but you have to like manually specify that because that or that kind of global one is just going to take ones that are like initially close on there.
Okay.
So like
Oh,
this yeah,
hold
sorry,
on.
go
Let me
ahead.
catch you on one piece of verbiage or vocabulary I want to clarify because I know we're looking at what we call Simulia right here, right? We're all
Yep.
familiar with the SOLIDWORKS interface. This is the Simulia interface. The solver behind the scenes is called Abacus, but a lot of times when we say Abacus, we're talking about a different interface. We'll call it Abacus Legacy a lot, right? Or Abacus CAE. That is like um, I don't know, the traditional abacus, I guess, the old school abacus, if you will.
Exactly. Yeah, and it can get confusing what's doing on there, but I think the best way, yeah, the Abacus Legacy, Abacus CAE on there, that was like one of the original FEA codes that was developed out there. With it, it was I believe in the late 70s, early 80s that it was as they're on it, and I mean, great what it's doing. And so what we're looking at here is Simulia, which is awesome. This is kind of our flagship product. So
Right,
behind the
right.
scenes it uses that kind of exact same Abacus legacy solver, but then you just have all these efficiencies. Like the main one, especially for us in our environment, is like, hey, you kind of live connect to your SolidWorks models, which is a huge deal of what you're doing on
Yeah.
there. Is like, hey, you can still do all your modeling in SolidWorks, but then you can use this high-end simulation. But then if you change your SolidWorks model again, you don't have to start your simulation from scratch. It's all connected, which is a
Right. I
huge
mean,
benefit.
yeah, that's a huge benefit for us, right? At MLC, everything that we offer is really always kind of a connected solution. We don't want any disconnects. This goes all the way back from when we moved from, AutoCAD to SolidWorks, or we didn't, but you move from 2D to 3D and you go like,
Yep.
okay, I don't want to go update a bunch of different DWGs or whatever. I put a hole in something, everywhere that something exists, there's a hole, and we extend that to everything, data management, simulation stuff. We couldn't do that, say, with Abacus Legacy, ANSYS users. There's a disconnect. Now it's like you take your SOLIDWORKS file, you save it, you open it up with this program, right? You could update it in SOLIDWORKS, the geometry updates over here.
Yeah, no, absolutely. And because on the previous one, there were some basic connectors where you kind of push and pull a little bit on there, but kind of what you have with your live connect, I mean, you can even set up like parameters in SolidWorks saying like, hey, this dimensions want to change, and you can then directly change that in Simulia. It's live connected, like you almost can't break it. You can't break the
Yeah.
connection. Where like before on there, it's like, hey, you could push some on there, you definitely couldn't push back, and so easy to break stuff. And it's like, oh, I have to start over on my simulation, have to do it on there. That is just like it just works. So
Oh
it's
yeah, that's
so
cool.
it's
I
nice.
guess you get some optimization benefits too if you say like, hey, here's a dimension in the model you can change. Then on the sim side, you can ask questions like, well, how thin can this thing get? How small can this dimension be before it's, not strong enough?
Exactly.
Okay.
Exactly.
Cool. I think I took you off track a minute ago. You were talking about context, though.
Yeah,
Now we have a general
I'm good to
contact
go
here.
wherever in this conversation. So it's a good time on there. But I mean, the general contact is just kind of so cool that it's fun to mention on there with it. But like this simple, I say simple example, simple to set up, pretty complex physics. Thankfully the programmers got to take care of that, and we can just utilize it there. But so like this is a simulation of just like crushing a soda can. I was
Okay.
doing on this front, and so.
Definitely
Um,
something you can't do in SolidWorks.
It definitely can't do there with it. But I mean, as you're crushing like parts of the can are like folding in upon itself, everything's there, like contact. So like I really can't predict what's going to be touching at different points
Sure. Yeah.
on there. So, but really all that was done from a contact perspective here and there is I just did a contact property, say, hey, I want some friction. Hey, like put in point two, and then it's already set up, so I won't set up again on here. But then I just click on general contact and assign that friction, and that's it. That's any contacts that come into there taken care of. So it's cool. And
That's
even just to
amazing.
show,
That's
yeah, I'll
amazing.
show the results there. Go
I
ahead.
sometimes, when I started getting into this interface, I'd get overwhelmed when I'd open up like general contact and I'd see like, oh my God, we have so many more options than you have in SolidWorks for pretty much everything. I mean, you get a bolt connector and I'm like, oh my God, there's so many more options. But the defaults were already set. So it's kind of like,
Yes.
when in doubt, just don't change what's there, and
Yes,
and you can move
exactly.
forward. Yeah, the other thing I
Yeah,
saw over there, it's like, the differences, I guess. Oh my gosh, that is amazing.
Yeah, it's all those power fully and upon self, see how much force it takes, but then yeah, those contacts on there. I mean, and even those complex simulation on there, I mean I don't know, it probably was like 10 minutes to solve. That's one cool thing here as well is that you have your option if you want to do some cloud solving capabilities, like hey, you're having complex simulations on it there. Hey, I can, keep my hardware open on my machine to keep on setting
Mm.
up other simulation things on there. It's cool. What was I can check on there, but they recently increased it where I think it's 190 up to 192 cores of solid, maybe
Uh,
196 on there, and then almost like 3 terabytes of RAM,
I
which you
saw
can do,
that.
which is just
Yeah.
wild.
They just did that. It was nice with this kind of platforms. They just push updates. You don't have to wait for like yearly release because it was just like an email that went out and they were like, "Hey, all the architecture now, newest Xeons, like H100 NVIDIA GPUs, and it was like, yeah, more cores, more RAM available." That was crazy. So, I mean, we're going here now to nonlinear, and is this an explicit dynamic solver?
This one explicit. Whenever you have kind of these complex contacts, or like, hey, things are changing constantly, like we see in this one, that's an explicit. Even though, like, hey, it's not like a highly dynamic in the sense like a car crash or a ballistics on there. This would be one you're kind of utilizing the efficiencies of the
Yeah.
explicit, where it would have to be
Okay, I
explicit
got you. And that
one there.
nonlinear and explicit solvers, those are abacus solvers. We could call those solvers
Yep.
abacus. We're in the interface of Simulia here, and then we have this general contact and contact efficiencies that we don't have in SolidWorks. The other thing I'm noticing here is different mesh elements, right? Like I see hexahedral meshing here, brick meshing.
Yeah, yeah. So that's a great call out. What you doing on that front? Because a lot of people that are at least familiar with simulation on some level on there are used to hey all your triangles, your
Yeah,
tetrahedral elements, what you do on there with it, which is great. I mean, you can mesh basically anything as far as there, but once you get into your Simulia, you do have options for a bunch of different types of elements, which really then the question is like, hey, why do I care about it on there with it?
yeah,
But it comes down to is it's ends up being like very efficient elements, and so like, hey, you can have more kind of structured meshing, which kind of gets you better results, or you're more efficient, meaning hey, I need less elements to get good results on there. And so we
right,
see,
right.
hey, I have my surface quad mesh, or if you're in 3D, kind of that brick mesh and things on that front. And so, like, yeah, I look at these places on the bottom. You see very, very uniform things with that. And so you have all sorts of, I guess, meshing options on there with it of what you're doing. But a big benefit, mainly from an efficiency standpoint. I mean, I'm still using tetrahedrals on a regular basic, especially for more kind of complex geometries on there. But you have those options and can add some more efficiencies in there, which is nice.
Yeah, it's pretty cool. I mean, I think that's another big reason to come really out of SolidWorks sometimes. Sometimes just the shape of stuff, like, somebody works with like a ton of I-beams and your tetrahedrons, it's like, well, do I want to go to shells on this or I want to stay solid someplace? Like, it'd be really nice to have bricks for those. And then something like this, to use a shell element on something thin like a can, but still be able to get outputs that show changes in thickness as things deform.
Yes. Yeah, that's a great call out. Because I'll go into SolidWorks because, like I mentioned, hey, this is live connected with SolidWorks. So like, hey, what
Right.
you're doing on there, it's a same on there. But yeah, but like I said, this can it's not uniform thickness. They want kind of like a stronger at the top,
Oh, it's not
and a stronger at the
uniform to
bottom on
begin with.
to begin with. So I mean, I look at this model right here and I see, all right, it's thick down here, really thins out along your walls, which they're optimizing. I mean, every little bit that they save in the can, obviously it goes on there, which I mean, you have your shell elements in simulation in general with it, but in Simulia you're allowed to kind of map variable thickness of what you're
Hmm.
doing on there, and so you can still have your thin elements. But then I just say, hey, let me get my thin surface to represent my shell, and then let me just use the body to then map it. And so like um, on
Yeah,
here,
that's another
yeah,
capability. It's just like well beyond anything we've had in SolidWorks.
yeah, and there's actually a lot of people that I've worked with that like that capability alone is kind of what they're going through on there because like you need shell elements like hey, different people with like thermoforming or different plastics or things with that. It's like hey, it's changing your thickness. Things on there is like you have to have something that can do varying thickness, and so like this is a little plot right here, just like mapping out okay what thickness is that shell mapped to. So we have like our thinner blue one, and then we see that the shell's mapped to a thicker up there
Oh
with it, but
yeah.
then it just kind of takes care of that automatically. But like I said, and I show kind of like random individual features which are applicable to a lot of people on there, but it's like it is just so broad about what you can do in there,
Yeah,
which is great, which is good
it's
and
good and
bad.
bad. It's a
Bad because
double-edged
yep,
sword. Yeah.
yeah. At first, it can be a little bit overwhelming, but like you had mentioned before, with it there is that when you set up these options, like with general contact, you see a bunch of options, and they're like, man, this is overwhelming. But I would say 95% of the time, hey, you can just do the default, and then the ones that you aren't, usually like we're kind of working together to develop that workflow of like, hey, what's the best way? But most of the time, hey, let me just use the default options, use what's in there. I don't need to understand this random setting that's used for probably one specific
Yeah,
company that
some
they developed it
esoteric
for on
thing.
there.
Yeah. It
Exactly.
has a lot. I mean, a lot of that's because Abacus Legacy, the solver behind the scenes, has been around forever, I feel like. And so it's just been developed and developed over the years, and there's just a wealth of stuff that you can do, and you can find documentation on and communities on, the DS knowledge base and the Abacus communities, where I'm like, oh, okay, if I do want to go into these obscure settings, I've been able to find um, examples and documentation, and really a community of users that's able to help here. Even guys who are only Abacus Legacy users, but I'll see like warnings in the solver, and I'll go search that up, and it's the same warnings because it's the same solver. So you have actually a super long history of documentation and users. It's pretty cool. On the I don't know, the breadth of things that it can do. I feel like I've been in this boat for a very long time with flow simulation. SOLIDWORKS flow simulation has so many different applications and things it can do, from stuff in perfect vacuum to aerospace things to thermal. And so it's one of the reasons I love to use it. It's why I kind of make it my main sim tool when I can, because it's really fun. I see different stuff all the time. But for customers that come looking for it, I think one, it can be a little intimidating, and then two, they usually have a real specific use case. So they're like, hey, I really don't need to learn all the things it can do, right? I need this customized. So that's generally how I do it. I'll go and say, all right, let's do a project together, or let's set up a workflow that's repeatable, kind of templatize everything, get you trained on the stuff
Exactly.
that's important to you. There's some things important to everybody, efficiency, accuracy, this kind of stuff, convergence. Um, but yeah, there's so
Yes.
much you don't need to know most likely.
Exactly. You bring up a good point on there as far as just kind of like that workflow development, or kind of like those success plans on there, because there's a law in the software, and like we mentioned in the beginnings, like there can be a condition out there like you have to have a PhD in order to run some of these on there.
Right.
But and I wouldn't recommend just coming into the software without like just trying to like blind like open it up and figure it out. Like, hey, we need a little bit of guidance that will they'll give it on there. But when I'm talking with different customers and working what goes on there, is that often we're kind of developing this like simulation success plan. You look on there, it's like,
Mm,
okay, what kind of
sure.
built-in built-in learning resources are already in there? What kind of examples on there with it? And then we often will have kind of a work development where we spend a day or two, like, hey, let's look deep at your application, list things on there, let's develop the workflow, let's help you guys so you can understand what's important to you. And so I've done
Yeah,
that several times on there with it overall. But like I said, taking people from that don't even know FEA on it
sure.
there to be able to get successful results with these high end tools
Yeah,
on it there.
that makes sense. So we take that approach, kind of a success plan approach with, a lot of different services, even from data management stuff to go, okay, we know what end state you want to get to. Let's talk about your timeline, personnel to go like maybe we need one meeting now, we need another one in 3 weeks. And there's a lot of resources for this stuff out there. Like Simulia in particular, we could go to the EDU space and kind of start with some examples that I cherry pick and go, okay, these are the most similar, like we're talking fatigue or something. Let's start with these that are real similar. Then let's do the real world project. Then let's build kind of the workflow that you guys will continue on. And sometimes it's all in 1 or 2 days, but a lot of times it's broken up over a few meetings.
Exactly on there, and it all comes down to like a kind of conversation, like where are you guys at today, your capabilities and things on there with it when having these aspects on there, because there's lots of aspects on there with it. So like one example for Simulia sets plans, like, all right, we have like kind of like said that first initial meeting, hey, let's just get you set up with the software, some base know-how of the interface on there. point you to some on-demand resources, which there's a ton on it there, and then we have kind of this um, more developed aspects of us. Okay, let's get some more advanced simulation support, and then hey, we can develop these workflows or give some more custom training on there. But there's so many resources. Like you mentioned before, Abacus CAE, the legacy Abacus has been around for a while, so like you see different like commands or warnings or things like there, and it's similar even though it's now like an updated user interface. But then even within your Simulia exactly, there's all sorts of resources. I think I pulled it up. Let's see. Yeah, so like
Sure.
online on the learn platforms, like hey, they have all sorts of I guess on-demand content, what you're doing on there, which there's a lot of content. Usually I'll point to, hey, what's your most applicable to you and things on that front. Cause like, hey, I don't want to go spend 150 hours where only 10 hours is applicable to me or whatever on that front. But it's there. It's
Yeah,
there if you need.
everybody gets access to this, when they buy a Simulia product. So they'll have, all the self-paced and examples to use as templates. But I like the success plan example you put up because everyone I talk to is different about that. They may come from a really strong FEA background, or they may come from nothing. They may want a bunch of hand-holding, or they may want to do stuff self-paced. So, we can kind of cater at all that, but everyone should be thinking about, in addition to the license cost on here, what they're going to do for ramp-up time, training or consulting services cost, upfront, to be successful with this type of stuff. And then ongoing, what level of support do you want? How proactive do you want us to be? Do you want to be on kind of a managed plan where we're really administrators, we're checking in proactively? Do you want to stay on just a basic tech support? You reach out when you have a problem. But definitely that initial curve is important to plan resources for to go get up to speed, get your ROI, and get comfortable with a workflow, templatized workflow you can repeat and be successful in the long term with. The other thing I point out to folks that is different about this software than the SolidWorks side of things is it is sold quarterly or yearly, right? So you cannot buy a perpetual license of it that just runs forever. When you stop paying for it, it will stop working. And so a lot of times you go, okay, we want to do this for this project that starts in 3 months. That's important to time out. Then we go, okay, let's not make the purchase until then, and let's line up a training date right then as well. So everything kicks off and there's not time wasted sitting on the license not being used.
Exactly, yeah. Because having that flexibility was doing on that front, just like, hey, let me get 3 months, let me get my results on it there. We can just go back to your linear stack solvers and solver simulation after that. But we have this application, hey, that's great, but just kind of what makes sense. But yeah, like I said, what your timeline of the project is important as well, because usually we'll kind of delay, hey, when you have access to the license to make sure that we're not wasting any time with that
Yeah,
with the time that you do have.
and I've definitely seen, some of our customers they run consulting houses, they're professional engineers, and they use this for their analysis tools. And I've seen them jump up and down between licenses, where for a while their base package will be have the nonlinear and linear dynamic package. Then for like a quarter, they'll need an explicit dynamic for a project. Then they'll drop that license. Then for like a quarter, they'll need to add fatigue, and then they'll drop that license. And that's basically it. I mean, those are the only. They're packaged up pretty nice, so it's pretty much like those options. It's not like
Yeah,
piecemealed out by each individual thing.
it's true. It's true, and I'll say, yeah, licensing, like I said, pretty straightforward as far as on there. And I'll run back to my one page on
Yeah,
here.
cool.
Like I said, I mean these kind of build on each other. One on the left, not very common because hey, usually if you're in this realm, I'll just go in SolidWorks simulation. If you're in this realm, you aren't going to get any better results going to a higher solver on there with it because they can both solve it. You're good for the most part there.
Mm.
But then, like you said, hey, that non-linear um one on here is that's really, hey, if we're going non-linear, we're going any sort of dynamic things there, that's really where we have the conversation. We have things there like, hey, should we be going to Simulia? Should we be doing this on here? But then, hey, your most complex ones, what you're doing, that explicit, which yeah, just can
Yeah.
solve
So it's kind of the
solve
choice.
anything that can be structured.
Yeah,
Yeah.
usually it's up and down between those, right? Like I'll see them hold simulation engineer as a base. They'll jump to the analyst level quarterly sometimes, depending on what they're doing. And then I know the only thing that I don't see here that you could add would be fatigue. They use the term durability for that. Am I right about that, or is that
Yeah.
included here?
Yeah, so fatigue. So right here, without
Ah,
how these
okay.
offers are set up on there, down these bottom left, is as included in the sim analyst offer was doing there. Behind the scenes, it uses the technology FE Safe, which is yeah, I mean, if you look in there, very well renowned fatigue algorithms and things with there. Yeah, I
Okay.
won't go into
Well, I
full
was wrong
details. You can
then.
do high
There's
cycle,
only,
low cycle in there.
yeah, the way they have it packaged now, there's only two levels really to think of then. You go engineer,
Yeah,
you go
and these are
analyst.
kind of the packaging of the offers I have on there, which makes it nice. There's kind of like kind of built-in aspects of kind of what's included in there with it. Technically behind the scenes, they have like different roles that are included in these offers on there, but for what we're looking at here, yeah, these two offers is really what we're looking at
Yeah, okay.
99% of the time.
Yeah, yeah, it
So
probably makes sense, like cost effective wise, if they're packaging it as well. And then you did mention, I was talking over you, but one cool thing about FE Safe was low cycle, right? That's something I know is not in SOLIDWORKS really. If you have
yeah,
low
not in
cycle
SolidWorks at
fatigue
all. Yeah.
events, yeah, that's cool.
Yeah. So it is cool on there. I mean, because I mean your high cycle, lots of cycles. Is it gonna fail? What's your damage? What's things on there? But low cycle, like, hey, that would be more of your classic, like the simple example, a paper clip. You're permanently deforming it, and then you're permanently deforming it back, and then eventually it breaks. But you're just having like
Used it a couple
very
times, yeah.
couple on there, and there's some really good built-in weld fatigue algorithms in there as well. As like, hey, that's taking in a lot of your theory. Okay, what kind of weld, what kind of process, those things on there, and so then it can predict very accurately kind of your weld fatigue, um, uh, which yeah, you just kind of put in. You also have some more like deep aspects of like putting in, okay, exactly what my surface finish is on there, and then kind of automates what some of the calculations are on that. So
Yeah.
it's a great tool.
Oh, we didn't even
So
talk about what you can get into in material properties and material calibration to make models. But I noticed before I drove you back to this licensing slide, you had a bunch of cool other examples up besides the can crush. And I was wondering if you just show me those
yeah,
again because I hadn't seen, all those. It looked like there's
abs-
like 50 examples up there.
absolutely.
Okay.
Yeah. So these are just kind of a bunch of different videos I've kind of just compiled into one on there. So these are basically all simulations that have been here. I guess yeah, run here in Simulia. Different things on there. So I mean, I could go kind of wherever. Obviously, I'm not going to go on all of them, but I'll highlight a few fun of them here. So like ballistics. That's a fun one up here with it. So
Whoa.
hey, just tearing through the metal plates of what it's doing there. And so I mean, explicit. You have advanced material properties as you're doing your damage material properties, which allows it to tear
Oh
and to see
yeah.
those aspects on there with it. You have your bullet impact over here on the right side of what it's doing there. And again, I'll show some examples of like, hey, here's are kind of like the crazy stuff that I can do on there. Doesn't mean like, hey, if I'm not this crazy, I don't have to go to Simulia. It's like, hey, if you're getting to like more than just basic nonlinear, that's where you kind of go into it. But it's fun to see kind of where you
Yeah.
go with it there. And so I don't know, a few other fun ones. I guess I have a compilation of several down here, so I'll play these, and this will just kind of go through a bunch of different
Yeah, classic
ones. Wire
three-point
crimping,
bending.
3-point bending, and what you're doing on there. Wire crimping, just a full like column crush, kind of similar to that can crush on there.
Yeah, it's
Blow
very cool
molding, that's
though.
a cool one on there. With it, hey, how's it thinning out? Thermoforming, hey, heat it up and then kind of suck it down. Where's it going to thin out? Where are things
Wow.
on there? Complex rubbers and contacts, crushing a bottle with water. There's these
Oh
things
yeah,
called
with
SPH
liquid.
elements. Yeah. So you kind of get that. Um, yeah, that coupling between your different physics on there, your multi-physics on that, and so again, all sorts of different things for what you're doing with it, but it's kind of a fun one. Yeah, car crash. I guess just of the door on there,
Yeah.
complex
Feel like a
rubbers
bollard.
and performance on there. So obviously very high level hydroforming
Oh, cool.
of forming stuff. Yeah, with water, complex billows, the fan braking as it hits against things on here, and so just I mean, obviously, just kind of very high speed of what it's going through on this, but it just kind of shows like, hey, if it can be structurally simulated, like this is the tool that that can do it.
This
So
is
this
the
is
one, huh?
this is the one. This is the one.
Yeah,
Yeah, some sheet metal forming.
these are great examples because they're all things I wouldn't do in SolidWorks Sim. So,
Yeah,
yeah, good examples. And I mean, sometimes I have folks too that come with no FEA background. They kind of want to just simulate every possible thing that's happening, and I always try to steer them down to like a more eh, concrete question. But this makes it look like, yeah, just the whole world.
Yes, and that brings up a great point on there. So, I'll often talk to people that's like, just because you can simulate it doesn't mean that you need to simulate it for your design on there with it.
Yeah.
So like very commonly, for example, like your damage properties, we're just seeing stuff like actually like rip and things on there. Really cool to see in the simulation, and it can do it in the simulation. There's very few situations where like for your designs you actually need those
Yeah.
material properties, and on there's like, hey, right, what about right up until damage, or like where it starts permanently forming, how much force to take on there with it, because you need to go collect deeper material data in order to put it in for damage things on there, which you can do. It's on there. It's like, hey, but that's gonna take longer. Let's
Yeah, I mean
yeah.
that's why SOLIDWORKS simulation fits the bill like 90% of the time. It's like, hey, we want to find out if this piece of metal is gonna break. If it is, that's a failure. So we just need to get up to the point it breaks, and then
Yeah,
we go,
breaking or
okay, we got to change the
permanently
design.
deforming even for this on there.
We don't
Exactly.
need to see it break. We
Exactly.
just need to know if it's gonna. Um, yeah, it's good.
Yeah,
Well,
no.
man, I appreciate you walking me through all this. Let's go back here. I know I've probably taken enough of your time this morning, but maybe if your game sometime again in the future, we could look at a project together. I can in here, get a little deeper on materials. You could correct some things I've probably set up incorrectly.
Hey, we'll look at it. We'll call it a good time. But no, like I mentioned in the beginning, whenever Sim's involved, I'm always down. So yeah, I'll have as many conversations as we want on there with it. But yeah, no, that sounds grand. I'm game.
Awesome. Well, I appreciate it, man. I'll be pulling you in on the next one.
Alrighty, sounds good.